This lesson is about evaporation and melting. So our question for this lesson is, what is evaporation? Our keywords for the lesson are evaporation, melting, impurities, and cooling. First of all, we need to start off with a knowledge check. So give yourself enough time to answer all 8 questions before the answers appear on the screen. So here are the answers. For question 1, when an object expands, do the particles expand? And the answer is no. The particles stay the same size, they just take up more space by vibrating or moving around more. For question 2, what happens to the particles in an object when it is heated? The particles vibrate or move around more, so they take up more space. For question 3, naming an energy store, it can be any one of these energy stores. And then in terms of question 4 as well, I've named all 4 of the energy pathways, so you only need to have one of these pathways to get the mark. For question 5, what is the unit of mass? It is kilograms. Name a unit of pressure, so a unit of pressure is the Pascal, which is a capital P and a lowercase a. And the unit for work is joules. It is the same unit as energy, because work done is a form of energy, and that is represented with a capital J. And then the last question, what is the equation for density? The equation for density is density equals mass divided by volume. So first of all, we need to compare evaporation and boiling, because a common misconception is that they are the same thing, when they are not quite the same thing. They are very similar, but it is not the same. So a liquid will change state from liquid to gas at its boiling point. However, water, for example a puddle, can change state even when the water hasn't reached its boiling point. So for example, a puddle could dry up even though the water hasn't reached its boiling point. It hasn't been hot enough for the water to reach 100 degrees. This is called evaporation. So it's when a liquid becomes a gas, it changes state even though it is below its boiling point. During evaporation, particles leave a liquid from its surface only. So you can see in the diagram, the left container, you can see that the particles are just moving away from the surface. Whereas during boiling, bubbles of gas form throughout the liquid. They then rise to the surface and escape to the surroundings. So you can see on the right, the container on the right, the fact that there are bubbles of gas within the liquid, and then the particles, when they move out, they rise to the surface and escape to the surroundings. Energy is needed for evaporation to take place in order to overcome those remaining attractive forces between the particles. We remember that solids have strong attractive forces between the particles. Gases then have the weakest forces of attraction between the particles. Liquids then have a reasonably strong attraction between the particles, more strong than gases but weaker than solids. So in order to have these weakened forces of attraction within a gas, we need to overcome the forces of attraction. So energy is required for that to happen, for a liquid to become a gas. Now, there is a YouTube video below, so either copy the link or search the video title. Make sure that you record your observations from the video. So this video is to do with the evaporation of water and ethanol. Once you've watched the video, you need to be thinking, why is there a difference between the the temperature of water and ethanol during evaporation. Okay, so make sure that you pause this video while you are watching the clip of water and ethanol evaporating so that you don't miss then any of the content of the video. Now we will talk about the difference between the temperature of water and ethanol during evaporation, so what the clip was trying to convey to you. So the straw placed in ethanol cooled down lots more than the straw placed in water. This is because ethanol evaporates more intensely, much faster and more rapidly than water. On the other hand, the water evaporates slower than ethanol. All of this is because ethanol has a lower boiling point than water. So ethanol will go from liquid to gas much faster than water will. Now we will quickly have a look at the factors of the rate of evaporation. So these are factors that will affect how quickly a liquid will evaporate. So these factors are forces of attraction / the boiling point, because the boiling point is related then to these forces of attraction, the temperature, the surface area, the wind and humidity. So you need to make sure that you have notes on these factors of the rate of evaporation. Make sure that you watch the clip below to then add to these notes. Either copy the link or you can search the title. Make sure that you pause this video while you are watching that one so that you don't miss any more content. Next we will talk about the evaporation of petrol. So petrol evaporates faster than water at room temperature. This is because the boiling point of petrol is lower than water's boiling point. As the boiling point of water is higher than that of petrol, petrol evaporates faster as it achieves that boiling point faster than water does. It's very similar to ethanol. Ethanol has a lower boiling point than water, so it evaporates earlier than water will. So petrol evaporates faster than most liquids, and this is to do with its weak intermolecular attraction, so the attractions between the molecules or particles. So remember those forces of attraction, they are weaker in petrol than they are in water, and that is why petrol has a lower boiling point than water. In comparison then, water evaporates more slowly than petrol because water molecules have what we call hydrogen bonding. This is a strong intermolecular attraction. Those forces of attraction between the particles, the molecules, is much stronger in water than it is in petrol. Now we will look at some examples of practicals to do with evaporation. So make sure that you have a look at both of these videos, either copy the links or search the titles, and make sure that you note your observations in your booklets. Now we are going to talk a bit about parts of the video and then also looking at why we sweat, because that links into the evaporation to do with our bodies. So different liquids have different boiling points, as we've already spoken about. Water, propanol and ethanol all have different boiling points. Water has the highest boiling point, then propanol, then ethanol. Okay, ethanol has the lowest. The result from the experiments in the video show that they have different rates of cooling, and they show us that evaporation causes cooling. So cooling is where the surface or the material or our body loses heat because of evaporation. It's to do with the energy required for evaporation to occur. The material loses energy. The closer the temperature is to the liquid's boiling point, the faster the rate of cooling. And this then links into why we sweat. It's to allow our bodies to cool down as the sweat evaporates from our skin. The evaporation takes up some of the energy, so we lose thermal energy as we sweat. So the evaporation of our sweat allows us to cool down. Now, there are certain ways that we can change the boiling point of a certain substance, for example, water. Impurities are one of these ways. So impurities, for example, salt, will raise the boiling point of water. Impurities are any substance that can be mixed or dissolved in the water or in a liquid. Tap water contains impurities, so it is not pure water, it contains impurities. So pure water is water that doesn't contain any impurities. Tap water does contain impurities, so it is not pure water, and therefore it will boil at a slightly higher boiling point than pure water. Pure water's boiling point is 100 degrees Celsius. This is then the reason why some chefs add salt to water when cooking, so that the food cooks faster. The video below shows an experiment to do with adding salt to water to show the change in boiling point. So make sure that you either copy the link or search the title into YouTube. Now we will look at changing the melting point. So when water is not pure, as we've said, it must have impurities in it if the water is not pure. It melts at a temperature below 0 degrees Celsius. So 0 degrees Celsius is the temperature at which pure water melts at. So by adding salt, which is an example of an impurity, to roads in winter, it lowers the melting point of water by up to 10 degrees Celsius. By increasing the melting point, this means that the ice melts at a lower temperature. And this is good for roads because ice then lowers friction to do with the cars on the road. So if there is no friction on the road, then cars will slide and they won't be able to grip the road properly. Okay, it can cause a lot of accidents. So that is why we grit roads. It's adding salt, not only salt but also sand. It's adding sand to the roads increases the friction. Adding salt to the roads as an impurity lowers the melting point of the water, which causes the ice to melt at a lower temperature. People who drive cars then can also put antifreeze in the cooling system of cars in winter for the same reason. It adds impurities to the water and then lowers the melting point. By lowering the melting point, it causes water to freeze into ice at a lower temperature. This then lowers the chance of the radiator in the car freezing and bursting. Make sure that you have a look at the video underneath. That is again another experiment adding salt, but this time to ice to show the change in melting point. So make sure that you copy the link or you search the video title. Make sure that you then complete this knowledge check now that it is towards the end of the lesson. So make sure that you give yourself enough time to answer all 8 questions before the answers appear. Here are the answers, so make sure that you mark and make any corrections in a different coloured pen. So what happens to a liquid at its boiling point? When a liquid hits its boiling point, bubbles of gas form throughout the liquid. These bubbles rise to the surface and escape to the surroundings. This then forms a gas. So the bubbles are a gas forming throughout the liquid and it then goes to the surface. For question 2, what happens to a solid at its melting point? The particles gain energy, causing the particles to move around and the forces of attraction to weaken. The solid then changes state into a liquid. The reason why we sweat is that the evaporation of the sweat from our skin cools down our body because it uses energy in order to have that change of state. So it then cools down our body. We have less thermal energy. Question 4, do different liquids have different boiling points? Yes. For example, water and ethanol have different boiling points. If you don't have those examples, make sure that you add them in your table. Question 5, why does petrol evaporate faster than water? It is because petrol has a lower boiling point than water. Remember that this is to do with the intermolecular forces, the attraction between the molecules in petrol. Okay, they are weaker in petrol, which means it is easier for the petrol to go from liquid into a gas, compared to water where the forces are stronger. It needs more energy to overcome those forces of attraction. Question 6, how can you increase the boiling point of water? A really good way of doing this is by adding an impurity, for example salt. This will increase the boiling point of water. Question 7, why is salt spread on roads in winter? It is because salt decreases the melting point of ice. This then causes the ice to melt at a lower temperature. We want ice to melt on the roads because ice will then lower the friction between tyres and the road. We need friction so that cars can drive safely on the road. Our last question then, what does antifreeze do to the melting point of water? Antifreeze decreases the melting point of water, causing the water to freeze into ice at a lower temperature. Make sure that you highlight your keywords. So evaporation is the process of a substance in a liquid changing to a gas state due to an increase in temperature. So remember that we need that increase in temperature, increase in energy to overcome those forces of attraction in the particles of the liquid to become a gas, because gases have the weakest attraction between the particles. Melting then is the physical transition of a solid into a liquid. And impurities are undesirable elements or substances found in a compound or mixture. They can be added to water to change the melting point or boiling point of water. That is the end of the lesson. Thank you.